Unit 5, pre-calc, 5-1, solving systems of two equations. Now, this may be a whole, like, whoa, wait a minute, I thought this was pre-calculus. Supposed to be doing a bunch of trig. Now we're going to enter into really an Algebra 2, Algebra 1, pre-algebra, even geometry review. So relax, enjoy it, but this is going to stir up a whole bunch of things that have been taught to you over the years. So this is a bit of a review, but I'm going to go over some general truths and then do a couple sample problems, and then we'll get real specific on the actual packet lesson. So that's where we'll do our sample problems in the packet. But for now, here's what you're doing. By the way, my brother-in-law is from Iran. His name is Farhad Golham Reza Bahabarabadi, just the coolest name in the world. Brilliant guy, came from Iran, went to Michigan State University, go Spartans, and got his degree in astronomical engineering, loves the galaxies and all that. And the reason I bring that up is, you know, what we're talking about here is the intersection of two lines, or we're discussing the intersection of a parabola and a line and all the possibilities. One of the greatest movies ever, Hidden Figures. You know, the genius mathematician, the gal who calculated how to leave an elliptical path and turn it into a parabolic path, and calculating the intersection points of a space shuttle ship coming back down to Earth. And of course, the astronaut wouldn't even get in that thing before she or somebody could calculate precisely the re-entry point of his capsule. Fascinating stuff. So we're scratching the surface about that. Yes, there are people calculating some phenomenal things about intersection points. So there's your warm-up. I got you? Did I set the hook? So anyways, we're going to be calculating where lines intersect. 99% of the time, you're going to have a situation like this, where there's my y-intercept. If you remember y equals mx plus b, rise over run, up 2, right 3. My y-intercept is -1, and I'd have to go down 4, right 1, 1, 2, 3, 4, right 1. I'd go like this, and this is where the intersection point would be. Now, I'm not going to calculate it right now. I'm just trying to scratch the surface and say 99% of the time you're going to find an answer, and that answer will be an x, then a y. The x value, then the y value. That's what you're trying to discover. If you notice something unique about this one, the slopes are the same. So think about that. If you go back to Algebra 2, if you've got a y-intercept of 1, but then you go down 2, bing, bing, right 1, because that's what it is, connect the dots, and you do the same thing with a different y-intercept, 1, 2, 3, 4, 5, 6, down 2, right 1. Now this isn't perfect, but you got parallel lines. Where do these parallel lines intersect? They don't. That's the very definition of parallel lines. So this is no solution, empty set. You could even just say parallel lines. That shows that you really know what you're talking about. And that's kind of what we're hoping, okay, as far as like great big old powerful asteroids coming our way. We don't want to hit those. So anyways, we want no solution. How about this one? Well, if you just take a little look at this and you say, hey, I'm going to divide that all by 2, I'd get x plus 2y equals 4. And this is kind of a weird one, but you graph this and you get a line. No, that's not an accurate drawing of this, but and then this is the same thing, so it'd be the same thing. Now look at it. What's a line? A line is a set of infinite points just connected together in a linear fashion. So how would I even answer this? Well, I just like this, same line, but I think they're going to say infinitely many. Now, I think your pre-calculus packet actually says all real numbers. Now, the reason I don't like that is, yes, there's an infinite number of points on this line, and yes, they intersected every single one of them, but what about this one, this one, this one, this one? So it's not all the sets of all coordinate points. So for now, just deal with it. I think pre-calc actually uses all real numbers. Now let's move on here. Solving systems of equations, but now we got lines and parabolas. So if you remember from algebra 2, y equals x squared is going to be a parabola. So think about what could happen. We could have a line come in and not intersect, so we'd say no solution. That's one possibility. We could have it come through, touch one point, and so we'd have one solution, which would be in the xy form. But then, what about a line that comes through and intersects the parabola at two solutions? So we'd have x1, y1, and we'd have x2, y2, just simply representing two solutions. Now here's some basic 101 skills for what we're about to do, okay, in our packet. So I got some do's and don'ts. The first three things are definitely do this if the opportunity presents itself and you find benefit from it. This is a big no-no. So the first thing I'm going to investigate is, what if I have two true sentences? 2 minus 6 is negative 4, 4 plus 2 is 6, and I just add them up. 4 and 2 is 6, negative 6 and 2 is negative 4, negative 4 and 6 is 2. Notice, I get a different but true mathematical sentence. You know what that means? It's okay to do that. How about just multiplying any equation by anything I want? See, 2 minus 6 is negative 4. I'm just going to triple every value. So I get 6 minus 18 equals negative 12. Yep, this must be okay. So I'll put okay, this must be okay. What about this one? What about subtracting equations that are true? In other words, 8 minus 2 is 6, negative 4 minus 2 is negative 6. Let's subtract the bottom one from the top. Well, what's 8 minus a negative 4? 12. What's negative 2 plus 2? That'd be 0. And then what's 6 minus a negative 6? That'd be 12. Guess what? It's okay to subtract the bottom equation from the top, or vice versa. You could subtract the top one from the bottom. These are all things that you're expected to have in your toolbox. Like, okay, I get that. I know, we can do this. Now, every now and then, a student will try some funky things. And notice how the equals are not lined up, but here they were. Well, this one was just multiplication. I meant here they were. This is a mess. So if you tried adding this, 12, then what would you do? Equals? Or would you wait for here? 8, 0? What? So you can't add or subtract those until you've lined up the equals. That's huge for today's lesson. I'll get to that when we get to the packet. Now here's two very easy examples of things you're going to be doing. You're going to be using elimination, which is also called addition. And some people call it linear combination, but I don't think you're going to hear that very often. And we're going to take advantage of this rule right here. Notice this is a line, this is a line. How do we know that? Because parabolas have a variable that's squared. And these are linear equations. So what do we have? We have two equations with two variables. What do we want? We want one equation with one variable. So how much time do I have? Plenty. I'm going to really pull these out, and I hope this grabs your attention. Aren't these opposites? In other words, if I add these right now, I'm going to get 3x and 2x is 5x. These are going to cancel. Ding, 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 ding. See, this is just spoon-fed because it's just set up and it just works out so nice. That's not always going to happen. And then 4 plus 6 is 10. Divide by 5, I get 2. Now remember, what we're trying to find is the intersection point. So there's going to be an x and a y. We only found the x. So we know our answer is going to be 2 comma something. Where are we going to find the y? Put this back into the top one or the bottom one. So I'm going to put it in the top one just because. Neither of them look any easier than the other. So that's 6. I'm going to subtract 6. So I get negative 2y equals negative 2, and I can just look at that and say y is 1. So there's the intersection point of these two linear equations. Okay? All right. Now, substitution. Well, this is a little different strategy, but the goal is the same. Remember, we had two equations, two variables, and then we performed addition, elimination. We got down to one equation, one unknown. That's always your goal. and look at y equals 2x plus 3. You see that? That is just begging you. Use substitution. It doesn't come around very often, but it shows up once in a while. So we're going to put this 2x plus 3 right in here. We're going to get 2x, see that's this, plus y, which is this stuff, plus 2x plus 3. See that right there? That's what equals y. That's why we substituted. Equals 7. Now this is 4x equals, I'm going to subtract 3, 4, divide by 4, I get x is 1. So I know my intersection point for these two lines are going to be 1, comma, then I don't know. So I'm going to plug that right in here. 2 times 1 is 2, plus 3 is 5. And there's my y. There's my intersection point for those two lines.